Hello friends and welcome at my channel. Today let's do one more function. We got x over x squared minus 4, a nice hyperbola, and we're gonna go through all the 7 steps. Step number 1, the domain. We are allowed to have everything but plus minus 2, obviously because we would have 0 in the denominator. Number 2, what's happening with the symmetry? Well, f of minus x is equal to minus x divided over minus x squared minus 4. This is just minus x divided over x squared minus 4. And as you can see, this is the same as minus f of x. So we are symmetric considering the origin. Great. 3. Limit x towards plus minus infinity. Obviously, in both cases, we are going to get 0 because the denominator is developing way stronger. What about limit x towards 2 from the right hand side of x divided over x squared minus 4? Well, you see, we're getting slightly bigger than 2. In the numerator, we're getting slightly bigger than 4 in the denominator. So this is a huge positive, small positive number. We're dividing a positive number by a very small, tiny positive number. So the result is plus infinity. What's happening if we are approaching 2 from the other side? Well, it's still positive, the numerator. The denominator is just a very small negative number. Close to 0 and still negative, so we're dividing by it, and we're going to get minus infinity. And as you can see, because of the symmetry, we know that it's going to be vice versa if we do it for minus 2. All right. Number 4, 0 points. X divided over x squared minus 4 equals 0, obviously if x is 0. Number 5, extreme values. F prime of x 1 times x squared minus 4 minus x times 2x only divided over x squared minus 4 squared. We're gonna get x squared minus 4 minus 2x squared divided over x squared minus 4 squared. All right, minus x squared minus 4 divided over x squared minus 4 squared. So this is the first derivative. Minus x squared minus 4, bringing it to 0, times minus 1, x squared plus 4, 0. Not a good idea if you have real numbers. It's always greater than 0, so it's never working. No extreme values. That's the way it is. All right. Number 6, points of inflection. Maybe we're luckier in this case. Let's see. We're considering the first derivative, which was minus x squared minus 4. I can kick minus in front, by the way. Minus x squared plus 4 divided over x squared minus 4 squared, and still I would like to produce a derivative of it. So just 2x times x squared minus 4 squared minus x squared plus 4 unchanged times 2 x squared minus 4 to the power of 1 times 2x divided over x squared minus 4 to the power of 4. Keep minus, we take x squared minus 4 outside of the parentheses. We would like to have 2x times x squared minus 4, then minus 4x times x squared plus 4. I think I'm done here. Divided over x squared minus 4 times x squared minus 4 cubed. Boom, bam. All right, 2x cubed minus 8x minus 4x cubed minus 16x divided over x squared minus 4 cubed. 2 minus 4 minus 2, x cubed. Minus and minus, minus 8 minus 16 minus 24, x divided over x squared minus 4 cubed. Can I simplify something? I don't think so. Did I forget the minus? Yes. Which is great because everything turns to plus. 2x cubed plus 24x divided over x squared minus 4. And I don't see how I can simplify. Okay, so that's the second derivative. Can we get it to 0? Let's see. We can take, so 2x cubed plus 24x divided over, what was that? That was x squared minus 4 cubed, I think. X squared minus 4. Okay, and we'll bring it equal to 0. I can take 2x outside of the parentheses. It's going to be x squared plus 12, still divided over x squared minus 4 cubed, equals to 0. So 2x is 0. That means x1 is 0. And x squared plus 12 is never 0. So the only possible point of inflection is 0, which is clearly the case here, should be. Otherwise, it's hard to maintain the symmetry considering the origin. But still, if you want to compute the third derivative, it's up to you. I don't want to do this. I just compute the second derivative at 0.1 and the sign of the second derivative at minus 0.1. If it's changing, I'm lucky. So, what do we have? We have 2 times 0.1 cubed plus 24 times 0.1 divided over, well, it makes no difference here. Obviously, we have a positive number, so it's positive. Now, 2 times minus 0.1 cubed plus 24 times minus 0.1 divided over a positive number. Is it a positive number? Oh, it isn't. My bad. I was too eager to finish. It's not. We have a negative number in the denominator. We have a positive number here. And in this case, we have two negative numbers, which are giving us positive numbers. So we do have a switch of the sign, which is great. So we have a point of inflection. Point of inflection. Great. At 0, and what is the y value? Well, let's see. We started here. 0, 0. 0 is a turning point. And a 0 point as well. Okay, I'm ready to plot the graph. We have troubles at 2 at minus 2. We're approaching 0 in both end sides. We know that. We're symmetric. We have no extreme values. Let's see here. If we are approaching 2 from the right-hand side, we're going to plus infinity, from the left-hand side, minus infinity. So, plus infinity here, minus infinity there. Because of the symmetry, it must be like here. And am I right? I think so. And here I must go like this because of the symmetry as well. I think I'm done now. Thank you guys for watching, and see you in the next video. Bye bye.